Hey guys, welcome to day 2 with the fractions in your equation. So yesterday you guys had just one fraction in the equation to practice. Today you're going to have more than one. So I'm going to show you, this is one of the activities that is on Google Classroom. It's a little riddle thing. The answer key is attached so you can check yourself as you go. I'm going to do a few examples, so you'll have 3 of them kind of done for you. So make sure that you are kind of paying attention, maybe even writing in your notes. Definitely writing along with me. So if you need to grab a piece of paper, go ahead and pause this and grab one now. All right, we're going to look at letter A off of this riddle sheet first. So notice we have 2/3 x plus 1/2 x equals 21. So obviously more than one fraction here. Since both of these terms both have an x in it, they are considered like terms. But I'm going to take care of the fractions first before I can combine like terms in this case. Okay, so I don't want to mess with converting 2/3 and 1/2 to the same denominator and then adding. I'm going to just get rid of the fractions first and then go from there. So, in order to do that, I'm looking at all the fractions in my equation. So right now, I have 2/3 and I have 1/2. I'm focusing again on the denominators, but I don't have just one denominator anymore. I have 2 of them to consider. So in order to see what I'm going to multiply the entire equation by, I need to find the least common multiple, the least common denominator between my 2 fractions. So the way that I think about this is, all right, I have a 3 and I have a 2. Well, I want to keep going up in multiples, so like 3, 6, 9, 12, and so forth, right? 2 would be 2, 4, 6. Okay, notice that 6 is the lowest common denominator that they have. So that is the number that I'm going to be multiplying this entire equation by. Okay, A is just like the number for this one, so ignore A right now. So I'm going to multiply by 6. Oh, 6, that's a 6, over 1. Let me rewrite that, that looks bad. Okay, so I'm going to make sure that I multiply it to each term in my equation. Okay, so both the left-hand side of the equal sign and the right-hand side to keep things balanced. So if I take 6 over 1 times 2/3 x. Okay, well 6 times 2 gives me 12. 12 over 3, well that's just 4, and don't forget that x. So that's 4x. When I do the next one, and it is, I'm going to take 6 over 1 times the 1/2, and that's a positive 1/2 there. So I'm going to say 6 over 1 times 1/2 x. Okay, well, 6 times 1 gives me 6. And 1 times 2 gives me 2. I still have that x. Well, 6 over 2 is really just 3. So I have a positive 3x, and if it's positive, I want to put that plus sign in here. Okay, and then I have 6 times the 21. Okay, bring down that equal sign. Make sure it's on the same kind of page here. So 6 times 21, let me think about that. That's what, 126? Yeah. All right, now I've gotten rid of the fractions, and I can go ahead and just take this equation right here and solve. Okay, so now I have 4x plus 3x, which is going to give me a total of, let me change the color real quick. A total of, I'm going to come up to the top, 7x. Okay, so I just combine like terms. Then, right, so then that's going to be equal to the 126. Next step, so remember I'm working in reverse order now of PEMDAS, which I don't have any more adding and subtracting, so I'm moving on to multiplying and dividing. So 7 times x, the inverse is going to be divided by 7. Keep things balanced. So x is going to be equal to, well, 126 divided by 7 is 18. So I have x equals 18. Okay, remember, in order to check that, I can go ahead and substitute that in my original. So I can say 2/3 times 18, and I can put that over 1, plus 1/2, again, times 18, because that's what I got for x. Again, put that over 1 since I'm dealing with a fraction. Let's see if that actually equals 21. So let's see. 2/3, so 2 times 18 would be 36. Let me use a different color. So that's going to be 36 over 3, which gives me a total of 12. Plus, well, 1/2 times 18, I can kind of think about that critically. Well, 1/2 of 18 is just 9. So does 12 plus 9 actually equal 21? Yeah, so I know that x equals 18 is the correct solution, okay? So I took care of getting rid of the fractions first by finding that least common denominator, and then I just had a normal equation to solve. All right, let's look at the next one. All right, so I don't know why it leaves some marks and not all marks. All right, so for this one's letter W on this riddle here. And again, well, it looks like there's only one fraction, but there's some things that we have to do first in order to solve it correctly. All right, so before I can take care of the fraction, I have something in parentheses, so I need to take care of that first. Okay, so I'm going to actually multiply and distribute like I would normally, use that distributive property. Okay, I'm only distributing to what's inside the parentheses. I can't do anything to this plus x over here yet because it's not in parentheses. So 1/4 times x is going to just be 1/4 x. And 1/4 times a positive 3, well, I can put that 3 over 1, and I know that 1/4 times 3 is just, well, I know it's going to be plus 3/4. And then I still have that plus x equals 2 to bring down. Okay, so now that I've taken care of that, I don't have any distributive property. I could combine like terms because I have a 1x here and that 1/4 x. However, I'm going to go ahead and take care of the fraction first before I combine like terms, okay? So definitely want to take care of that distributive property before you take care of the fraction. All right, so let's see here. Well, the only denominator I have in any fraction in my equation is a 4. Okay, well, 4 is going to be my common denominator. I don't need to go up any higher. Okay, I don't need to go up to 8. I don't need to go up to 12. 4 is just fine. So if I multiply this entire equation by 4, well, I can put that over 1. So 4 times 1 gives me 4. 1 times 4 gives me 4. Well, that's just 1 whole, and there's still that x there. Okay, so I have 1x. And then I'm going to say 4 over 1 here, times, so I'm just distributing this. I just wrote it over here, though. So 4 times 3 gives me 12, and 1 times 4 on the denominator gives me 4. Well, that simplifies to just 3, and that's a positive 3, so make sure you put that plus sign there. And then you still have, it's a positive, so that's why I brought that plus sign down. So 4 times 1x is going to be 4x. And lastly, remember you have to do both the left-hand side for everything and the right-hand side. So I have that equal sign I'm going to bring down. And 4 times 2 lastly gives me 8. Well, now I don't have any fractions, and I can go ahead and solve this like a normal equation. So I'm going to look and see. I already did my distributive property, but my second step is combine like terms. So I have 1x plus a 4x. Okay, so that's like a plus a 4x. So that's going to give me a total of 5x, and I still have that plus 3, so I'm going to bring that up, I guess. And then equals 8. Okay, I just wrote down everything I haven't used. Okay, so now I'm on to inverse of PEMDAS. So I need to take care of this plus 3 first, since it's adding and subtracting. Subtract 3 to use that inverse operation. So I have 5x equals, well, 8 minus 3 gives me 5. And then lastly, I know to divide since it's multiplying to start out with. Keep it balanced. So that gives me 1x on the left-hand side, or just x. And 5 over 5 gives me 1 whole. Okay, well now I can check it. So if I substitute that into my original, it's saying 1/4 times 1 plus 3 plus 1 equals 2. So 1 plus 3 gives me 4. Well, 1/4 of 4 is just 1 whole. So 1 whole plus 1 whole equals 2. So yeah, that does work out. So I know that x equals 1 is my correct solution. And then one last one. This example you saw on my IXL video, where it's kind of one of those special cases. Gotta love it, right? Okay. So for this one's a little bit different because you'll notice that in the numerator of the fraction that you kind of see here, you have a quantity, okay? It's not just one single number. You have a 3x plus 3. That's a quantity, okay? So notice that I automatically put parentheses around that. So when I'm going to solve this, remember, let me get this down over here. Excuse me. So remember, this is going to be, first of all, distributive property, which we don't have. Second of all, combining like terms, which we don't have at this point in time. So we're on to that reverse order of PEMDAS, okay? So I'm starting from the bottom, working my way up. Okay, so adding and subtracting is something that I have to do first. But when I look at that, I see a plus 3, but I cannot do that because this big division bar here is acting like that grouping symbol. That's why I put the parentheses there, to actually show you the grouping symbol. Notice parentheses is the very last thing that we can do, okay? So I cannot deal with that plus 3 at this point in time. I have to move on to multiplication and division, okay? So right now I have a divided by 4, okay, in my denominator. So the inverse of dividing by 4 is to multiply by 4 over 1, okay? Just multiply by 4. Well, I have to do that to both sides to keep things balanced. Well, when I have a numerator of 4 and a denominator of 4, that gives me 1 whole, and that just cancels, leaving me with the quantity that was at the top. Okay, so now that there's no denominator, notice that I kind of dropped the parentheses because I kept it together. I don't need those parentheses anymore. And then 12 times 4, I have 48. Okay, now, again, I go back to the bottom of PEMDAS. So adding and subtracting. Well, I have that, and I don't have any special cases going on with that big division bar, so I can just subtract 3. Subtract 3, so I have 3x equals 45 when I subtract that. And now I can do my last step, which is dividing by 3 using that inverse operation. So now that gives me 1x, or just x, and 45 divided by 3 is 15. Okay, so I think my solution is x equals 15. Let me check it real quick. Guys, make sure that you're checking because it's so easy to make a simple mistake on these. So I go back to my original, and it says 3 times x, which is 15, which I think it is, plus 3 all over 4 should equal 12. Let's check. So this is where I go in the correct order of PEMDAS, okay? Because I'm not solving anymore, I'm just checking. So parentheses. So remember, this still acts like a grouping symbol. So I need to do 3 times 15 first. So that's 45. 45 plus 3 up here should give me 48. So that's 48 over 4 equals 12. Does 48 divided by 4, in fact, equal 12? Well, yeah, it does. So I'm going to get 12 equals 12, meaning that, yes, x equals 15 is the correct solution. Okay, so keep these in mind. Make sure that you watch this multiple times if you need to. Make sure you're asking questions if you need to. And I will be happy to help. All right, good luck, guys.